Hello everyone, my name is K. Ranjit Kumar. Today I am going to give a seminar on Fourier series. It is a important mathematical tool in signals and systems. In this we are going to talk about the trigonometric Fourier series, exponential Fourier series and cosine Fourier series and Dirichlet's condition. We have to discuss on these four topics. Basically, the Fourier series helps express periodic functions as sum of sines and cosines. It means the Fourier series is a mathematical method that follows us to represent a periodic function as a sum of simple sine and cosine functions. It was developed by Joseph Fourier and is widely used in electrical engineering, communication, and vibration analysis, and many other fields. In simple words, the Fourier series breaks down a complex periodic signal into a waves. It was developed by the Jean-Baptiste Joseph Fourier and it is used in full in signal processing, vibration analysis, and etc. The periodic functions of the Fourier series is a periodic function f of t is periodic if f of small t plus capital T is equals to f of small t. Here the t is the period. For example, sin of x and cos x repeat after 2 pi, then it will be called as periodic signal. Here the Fourier series works only for such periodic functions only. This is why understanding periodicity is essential before applying the method. The Fourier series breaks periodic functions into simple harmonics. The key idea of this is approximate any periodic function ultimately using for sine and cosine terms. The trigonometric Fourier series expresses a periodic function as a sum of sine and cosine terms. The general form of the trigonometric Fourier series is f of t is equals to a naught plus summation I is equals to n is equals to 1 to n a n cos n omega naught t plus b n sin omega naught t, where the omega naught is equals to 2 pi by t. It is the fundamental frequency of the signal, and a n and b n are the Fourier coefficients that we calculated from the function. This representation is extremely useful because sine and cosine are simple to work mathematically. In this, we can know about how to calculate the coefficients of trigonometry. Here, the coefficient a naught is equals to 1 by t integral f of t dt, and a n is equals to 2 by t integral f of t cos n omega naught t dt, and the last formula coefficient bn is equals to 2 by t integral f of t sin n omega naught t dt. Here the coefficients are found using integration over one period of the function. Here a naught represents the average value DC component and an and bn represents the amplitude of cosine and sine components of different frequencies. By calculating these, we can construct the original signal accurately. Until the before slide, we have learned about the trigonometric Fourier series. From this, we can learn about the exponential Fourier series. We can also express the Fourier series using exponential functions. Here the formula is f of t is equals to summation n is equals to minus infinity to infinity Cn e power jn omega naught t, where The Cn is 1 by t integral f of t e power minus j n omega naught t dt. It provides the compact presentation using complex exponentials. This form is compact and elegant. It uses Euler's formula e power jx is equals to cos x plus j sin x. This is especially useful in electrical engineering and communication systems, where complex exponentials are common. The advantages of exponential form is it simplifies mathematically manipulation, especially in differential equations. It is symmetry between positive and negative frequencies. It is useful in engineering applications like Fourier transforms. It means the exponential form simplifies the differentiation and integration. It makes convolution and frequency domain analysis much easier. In signal processing, this form is preferred because it works naturally with phasors and complex algebra. These are the advantages of exponential form. Now we can learn about the cosine Fourier series. It was also called as even functions. If a function is even, we only need cosine terms, since sine terms are cancelled out. This reduces computation and simplifies the Fourier series. This is why the cosine series are commonly used in applications like image processing and heat transfer problems. For even periodic functions, f of t is equals to a naught plus summation n is equals to minus infinity to n an cos n omega naught t, and the only cosine terms are present. It is easier to compute the even symmetric signals. In this, we can learn about the Dirichlet's conditions. The Dirichlet's conditions tells us when a Fourier series converges to a function, the function must. There are four conditions. The f of t must be periodic. It means the periodic means we have to take only the cosine and sine waves, and the f of t must be absolutely integrable over a period, and the f of t must have a finite number of discontinuities, and the f of t must have an infinite number of maxima and minima. If these conditions are satisfied, the Fourier series will correctly represent the function. The physical interpretation of Dirichlet's conditions are it ensures the series approximates the function well, and in practice most physical signals satisfy these conditions. A discontinuity series converges to average of left and right limits. It means the physically the Dirichlet's conditions ensure that the function is well behaved. For example, a signal with infinite discontinuities cannot be reconstructed with infinite sine and cosine terms. Here are some applications of Fourier series. The Fourier series was widely used in the signal processing and audio compression, heat transfer analysis, and vibration analysis, and the electrical engineering. These are the some applications uh, widely used in. Essentially, wherever periodic signals are involved, Fourier series can be applied. Here we can conclude the Fourier series as the Fourier series is a powerful mathematical tool that allows us to decompose periodic signals into simple harmonic components. It is a bridge between time domain and frequency domain analysis, forming the basis for Fourier transform and many other techniques in modern engineering. And in this, we have seen the trigonometric Fourier series and the exponential Fourier series and the cosine Fourier series in suite of different problems. The Dirichlet's conditions are ensure convergence. Thank you everyone for paying your valuable time to watch this.